Because for the strong start, we never use the buffer equation, right? So that's huh?
So basically,
the campus over there. To like walk. To like walk.
Yes. Yep. Half the original. Right item. That's not you.
Like I swear, this class like laughs at random intervals. I don't know why.
I don't either, but I don't question. Next data point. Now we're at 30 ml of the NaOH that was added. So we go through the whole thing again. That is still 0.004 originally. That now is 0.003 moles. Still the limiting reagent, but the HOCl now is going to go down to 0.001 moles. Are you with me? See what we're doing? Now this over here, it has gone up to 0.003. Right, you're already there, huh? We can use the buffer equation. We have acid and base. So jump to this thing. 7.46 plus log of bah. You get what? 7.94. Make sure you can get 7.94. Tell me if you don't. So for 30 ml.
That's not.
Kyle, don't say anything. It's good. What are you not liking? This is a beautiful
I
graph.
didn't say anything about
Oh,
it
okay,
this
okay,
time.
okay, okay.
All right, 7.94 you said?
Yeah.
7.94.
I was just like,
What?
Nothing. It's nothing.
Wait a second, how did you do your notes?
No,
Drew. Don't.
I'm busy. Don't bother me.
Everybody good with 7.94 or 7.9 something?
Next time.
What point is next?
Stop.
Now we're going to hit the equivalence point. We've been creeping up every time by a thousandth of a mole. Now we're going to get to 0.004 moles, and what happened?
Equivalent.
Right.
Oh.
So at 40 ml of NaOH,
Dude,
that means that this is going to be 0.004. This goes to 0, and this goes to 0. So at this point, all of the original acid now will have been neutralized. That's 0. This goes up to 0.004.
I did not get the right answer.
Why did you say that if you're also prime?
Of this point? Well, let's find out. Before you do, no, time out. Can you use the buffer equation? You cannot use the buffer equation. If we're at the equivalence point, does that make automatically the pH equal to 7? No. It is for a strong to strong. And you can see the trend of this data. I mean, we're way above 7 now already.
because there's some of them.
Oh, because you can only use the buffer equation if you have a buffer. If you have an acid and its conjugate base present. We don't have any acid. There's only what? That's gone. That's gone. The only other thing in the reaction is water and OCl. Now this OCl is basic, yes? Why? Because that was a weak acid, so its conjugate base is a base. So this solution is now basic. Can you determine its pH?
Oh, yeah, you just use that.
This is dictating the pH.
Don't you just negative log that?
Yeah.
No. This is a base, but what does it do? It's going to produce some hydroxide ions in water. You got to do another ice table. Now in this case, you're stuck doing an ice table.
Oh, no.
Can't use the buffer equation, can't use any shortcuts. I guess later on for the ice table you can use a shortcut, but OCl negative is going to react with water. Now, Eric, you asked a great question, very common wrong perception.
Yeah.
No, that's all right. I'm not making fun of you at all. The question was, can't you just take the negative log of this? And the answer was no. This is not, I mean, even though this is a base, the pH is what the negative log of the hydrogen concentration is. This is not going to give you the hydrogen concentration, is it? And this is not going to give you the hydroxide concentration by itself. You have to react it with water, right? And then it takes the hydrogen off of water and makes HOCl plus hydroxide. This is what we need. How do we find it? It's an ice table. We know the initial concentration of OCl. What is it?
0.004.
No, no, no. That's the moles.
Divided by
Oh, right. You have to divide it by its volume.
Hey.
No.
0.08.
Rashid, stop it.
Isn't it with 0?
Look, it's 0.004 moles divided by the total volume, which is 0.08.
Whoa.
Oh, shoot! Yes, the total volume. Be careful. So it's 0.05.
I always yell. I know.
Yeah.
Remember, all the HOCl was gone before, so those are zeros. Can we use an ice table shortcut at this point? Yeah, as long as you don't start with any products, you can use the ice table shortcut, which is, what would it be? This is going to be the X value. X equals a hydroxide concentration, which equals the square root of what? In this case, the Kb of hydroxide times the initial concentration of OCl, which is 0.05. What is the Kb?
The inverse of 3.5.
Yeah. Is this annoying to you? These are all these little tiny things. It's not hard, but just make sure you're organized. And you know what you're doing. Yeah.
Wait, can we use? Is it 5%?
Oh yeah, these are tiny numbers. Use
Okay, so just.
Yep. So, anybody got the Kb? It's Kw divided by this number. 1 times 10 to the negative 14 divided by this gives you.
On the testing of this, we just need to know like conceptual stuff on this, not actually do it.
Oh yeah, you'll do it. Farouk?
How friendly are these numbers going to be?
Not so friendly. If I'm going to have you do something like this and not allow you to use a calculator, they'll have to be very friendly.
It's
How about we have to use a
Oh, we have to do that on the test, no?
Barney friendly?
Barney was a
Oh.
Oh, Mickey Mouse.
Mickey Mouse?
Barney's a pretty purple dinosaur. It's gonna be hard.
He's friendly though.
Good jail.
Sorry, 2.9 times 10 to the what?
-7. You can bring it inside.
Barney went to jail.
Jail?
Yeah.
I heard from
Yeah.
Barney died.
All right, take a look up here. Enough of these random questions.
You know,
The
please
hydroxide
the actor.
concentration is square root of the Kb, which is 2.9 times 10 to the negative 7. Is it clear how that number
2.9
times the initial concentration of OCl, which was 0.05? That's the hydroxide. Find pOH, then change it over to pH. All for this one silly pH at the equivalence point. And what do you get?
10.08.
10.08. I like that. That was 40 ml. Oh my goodness, it's going to be a big jump here.
You did it?
I didn't say anything yet. Yes.
Yeah.
That's because there's nothing bad to say about it. It's perfect.
Oh yeah, sure.
I think you might be a little biased.
No.
You can't be biased about perfection.
Oh,
Either it is or it isn't.
One must be perfect to experience perfection.
LaFon just turned down.
Oh no, I didn't say that. But that is.
Oh.
Any questions about the equivalence point?
What is that noise?
What are you saying? Because I hear voices.
Where did you turn that off?
Ending.
Well, that was fun. Should we do another data point?
Yeah.
That's what's great about this chapter.
10.08.
There's always more.
What's the T?
We should be.
Oh, 10.08.
Keeps on giving.
What happens if you put one more?
Thank you, Tarun. Appreciate that. All right, before we do the next step, let's just make sure that this is clear. I would suggest you write it and highlight it. The equivalence point when you're titrating a weak acid, it must be basic. Because at the equivalence point, you have that conjugate base there that determines the pH. Good.
So do you have to do the ice table for all the next points because we have no HOCl?
No, no, you don't. Good question. We'll see. We'll see if we can come up.
Because now the other one's the limit here.
Yes. Leaving what?
More.
That in excess.
Oh, I know.
Portable hybridization.
What's your next reading quiz?
I'll show you. Check it out.
Friday.
Tomorrow.
Sweet.
I should be wearing that tomorrow.
Alright, tomorrow.
Mr. Last Spirit Week of all high school career.
Alright, tomorrow.
Are you gonna wear a hat?
I hate you so much.
Yeah, I might.
Hey guys.
Hat for charity.
Ready?
I still don't know where that hat went. The one that has the roof.
On
Propeller?
popular demand, we have the next data point.
Okay.
Okay. Now we're going to have an excess of hydroxide. Now we're past the equivalence point, and the sodium hydroxide is going to be the one that dictates the pH, because that was 0.004. This one is 0.005 mole. The HOCl was the limiting, that goes to 0. This is the XX, that goes to, not 0, 0.001. That goes up again to 0.004 because that was determined by the amount of HOCl, the limiting. What's in the solution now? There's hydroxide ions, and there's OCl ions. That's a base, that's a base. Yeah?
So it's big.
Yeah.
Seem complicated to come up with the pH of this one?
No.
No.
Do the POH thing that you have right above your head. You can't.
It's not a buffer.
Like this, Spencer.
Here's what's cool. This is a weak base, right?
Yeah.
How much hydroxide is this going to produce?
Not
A
that.
tiny little bit. Tiny little bit. We have an excess of hydroxide from the added amount.
Negative.
This one dictates the pH. This is negligible because it gives off so little hydroxide.
Oh, good.
So the point is, past the equivalence point, just use the excess of hydroxide to determine the pH, ignoring the amount from the weak, from the conjugate.
I'm so
Wait, explain that to me. What?
Explain that to
in
me
the
why.
club.
This is a weak base, right? Yeah. So this is going to produce hydroxide, but it's a minuscule amount. Okay. This is not a minuscule amount. So this is going to produce like 0.00000 something moles of hydroxide. Plus this amount, that other amount was negligible.
Okay, so basically we can just like
Just ignore this and use that.
you just find the concentration of that and then
Yes.
negative log.
So the question is, do you take negative log of this to get the POH?
No.
No, because it's got to be the concentration. It's not concentration, that's mole. So that is a common mistake too. People say, oh, I know, past the equivalence point, I just use that. So they say, oh, the pH is 11. No, it's not.
Mine
Is that what you did, Valerie? Yeah, you got to have the concentration.
Okay, so past the equivalence point.
So it's 12.05.
Yes, that's right.
The problem is, I know what I'm doing now,
Of
I'm
the
gonna go
excess
home and not know
hydroxide.
how to do any of it.
That's the thing, yeah. That's why I said start over.
We can totally forget about this during the quiz.
Oh, no. That's why you do the practice problem. So yeah, there's our hydroxide. You get 12.04 or 12.05 for the pH. Calculate it, make sure you can. So at 50 ml, we're up to 12, way up here.
In Q. Which for more? So the review question is connects 30 to 40.
Right. Any of those 11 questions. Not necessarily the assigned questions from that chapter, but any of those. We're going to do one more data point. What are we seeing on this graph? We see a sharp increase, then a leveling out, and then a sharp increase.
Looking like a cubic.
Does it just
function
keep going
to
like
me.
that?
Mm-mm.
No, it's going to have to level out. Because now we're at an excess of hydroxide. So it's going to level off in a hurry and just do that. Let's find it. One more step. So at the point at which 60 ml of sodium hydroxide has been added, that is, let's just get rid of all that. I think you're kind of getting the idea, right?
Yeah.
Do the pH in that one. 6.
Put 06 moles, and that goes to 2. Ow. OH negative.
Hey, Mr. Moore, who's not here tonight?
equals 0.002 moles.